Dear students, today we'll see the fourth part of DCET 2021 solved question paper. So let's start with the first question of the fourth part. Question number 61. The assembler directive gives a symbolic name to a numeric constant in ARM is. Options are EQU, option B align, option C export, option D area. Now we know that assembler directives are one which gives direction to the assembler. They are not like instructions. They are assembler or directives. Now assembler directive which gives a symbolic name to a numeric constant. So say for example, if you want to equate something with numeric constant. So you are going to have a name, and to that name you are going to assign some numeric constant. So wherever you use that name in the program, that numeric constant value will be replaced by that name. So there we require a assembler directive called as equate, and short form of that is EQU. So EQU is the assembler directive which gives symbolic name to a numeric constant in ARM. So here option A is the right answer. So here you can see the definition EQU. The EQU directive gives a symbolic name to a numeric constant, a register relative value or a PC relative value. So here we have shown one example. So in this example you can see that ABC is a name. Now this is a name. You're going to equate that as 2. So ABC will be assigned the value 2. So this says that it is going to assign the value 2 to the symbol ABC. Okay, so this is what equate assembler directive is going to do. EQU assembler directive is going to do. So here option A is the right answer. Then we'll go to the next question. The GPIO, that is general purpose input output registers, used to control port 0 and port 1 in LPC 2148 ARM controller are. Options are PLL, a configuration register, a timer register, legacy registers and enhanced registers, register bank. So here when we studied GPIO in our ARM controller, when we studied about LPC 2148, the registers used in GPIO were coming under the category of legacy registers and enhanced registers. So here option C will be the right answer, that is legacy registers and enhanced registers. So here every physical GPIO, that is general purpose input output port, is accessible via either the group of registers providing an enhanced features and accelerated port access or the legacy group of registers. So here option C, that is legacy registers and enhanced registers, will be the right answer. Then we'll go to the next question. Which of the following statements is true with respect to embedded system when compared to a general purpose computer? Now if you think about embedded system, it will be a special hardware with a special operating system, that is real-time operating system, which will be assigned a given application. Whereas a general purpose computer will be a general hardware with a full operating system, that is a general purpose operating system. Okay, so here the statement which is true for embedded system is given in option A. It is a combination of special purpose hardware and embedded operating system, because option B is the definition for a general purpose computer. Therefore option A is the statement which is true for embedded system. So embedded system is a combination of special purpose hardware and embedded operating system. So option A is the right answer here. It is a combination of special purpose hardware and embedded operating system. Then we'll go to the next question. Operational quality attributes of embedded system is. So in embedded system we have operational quality attributes and also non-operational quality attributes. So here options which are given as response, evolvability, portability, time to prototype and market. So out of this, operational quality is response, And non-operational qualities are evaluability, portability, time to prototype, and market. So option B, C, D are non-operational, whereas option A is response, which is operational quality. So here option A will be the right answer, that is response. So here, if you see the concept, operational quality attributes, these are the attributes related to operation or functioning of an embedded system. The way embedded system operates will affect its overall quality. Operational or quality attributes are response, throughput, reliability, maintainability, security, and safety. So out of this, the response option is there in our question. So a response come in operational quality attribute. Then if you see non-operational quality attributes, these attributes are not related to operation or functioning of embedded system. Non-operational quality attributes are testability, evaluability, portability, time to prototype and market, per unit, and total cost. So here, as we have seen the options, option A will come for operational or quality attributes, and option B, C, D come under non-operational quality attributes. So here, option A, response, is the right answer because it comes under operational quality attributes. Then we'll go to the next question. In MSP 430, MSP stands for. Now here MSP stands for mixed signal processor. So here option C is the right answer, mixed signal processor. So here MSP in MSP 430, MSP means mixed signal processor. Then we'll go to next question. The addressing mode for the instruction move at R10, comma 0 into bracket R11. So in MSP 430, what it is going to do? Okay. Now here it is going to copy the data from the address which is given by the registers. So here address is given by the register. So at R0 means address is in R0, and then at that address what data is there, that is going to be operated. So here, because the address is taken indirectly through a register, this comes in indirect addressing mode. So option C will be the right answer here. The addressing mode for move at R0 0 bracket R11 in MSP 430 is indirect addressing mode. So option C is the right answer here. So the type of given instruction is indirect register mode. So here indirect addressing mode, that is type option C is the right answer. Then we'll go to the next question. Byte addressable registers used in non-interruptible input output of MSP 430. So if you want to have non-interruptible input output register, then it is direction register. So option A, that is PXDIR direction register, is the byte addressable register used in non-interruptible input output of MSP 430. So here in MSP 430, the register PXDIR controls the direction of the port, input or output. Here X refers to the port number, example P1DIR for port 1. Writing a 1 will make the corresponding port bit as output, and a 0 would make the corresponding port bit as input. So here option A will be the right answer, PXDIR, that is direction register. Then we'll go to the next question. In a Verilog, 7% minus 2 evaluates to how much? Okay, so if it is 7% minus 2, then the answer it will evaluate to is plus 1. If it is minus 7% 2, then it is minus 1. So here it is 7% minus 2, then the option should be plus 1, that is option B. So here Verilog operators operate on several data types to produce an output. Minus 7% 2 evaluates to minus 1, takes the sign of the first operand. Similarly, 7% minus 2 evaluates to 1, that is plus 1. So here option B, plus 1, is the right answer. Then we'll go to the next question. Format specifier person C is decimal format, a character, string, or real in exponential format. So here format specifier person C is for character. So here you can see format specifier and type. Percent C is for character, percent D is for signed integer, percent E is for scientific notation of floats, and %f is for float values. So here option B will be the right answer, that is character. Wait exclamation mark A, execution will suspend until A becomes. So you are going to wait till A becomes 0. So whatever is the value of A, till it becomes 0, the execution is going to wait. It will be suspended. So execution will be suspended till the value given after the wait in the bracket becomes 0. So here option A, 0 is the right answer. Then we'll go to next question. The force which causes to flow the electrons in any closed circuit is known as. So electrons to flow will be caused by potential difference, or it is also called as electromotive force. Okay, so option B will be the right answer, that is potential difference. So here the force which causes to flow the electrons in any closed circuit is known as potential difference or electromotive force. Then we'll go to the next question. Which one of the following theorem is the dual of Thevenin's theorem? If you see the dual of Thevenin's theorem, then it is Norton theorem, which is the dual of Thevenin's theorem. So option A is the right answer. So here Norton's theorem. Norton's theorem is also known as the dual of Thevenin's theorem, because in Norton's theorem we find short circuit current, which is the dual of open circuit voltage, what we find in Thevenin's theorem. So here option A, Norton theorem, will be the right answer. Then we'll go to next question, question number 73. Two resistors are said to be connected in series when options are both carry the same value of current, both current equals the sum of the branch current, sum of IR drops equals the applied EMF, same current passes in turn through both. So if you're having resistors connected in series like this, and then there is a current flowing I, the same current I will flow in both the resistors. So both carry same value of current I. So option A is the right answer here. Both carry the same value of current. Then we'll go to next question. The direction of induced EMF can be found by. So when we study electromagnetic induction, the direction of induced EMF after mutual induction can be found by. Okay, so after mutual induction or self-induction, the direction of the induced EMF is found by a law which is called as Lenz's law. So option A is the right answer here, that is Lenz's law. So option A, Lenz's law, gives the direction of induced EMF. Then we'll go to next question. Two similar electric charges of 1 coulomb each are placed 1 meter apart in air. Force of repulsion between them would be nearly dash Newton. So when two similar electric charges of 1 coulomb are placed 1 meter apart, then the force of repulsion between them will be 9 into 10 to the power of 9 newtons. So option B is the right answer, 9 into 10 to the power of 9 newton. So here you can see it is option B, that is 9 into 10 to the power of 9. Then we'll go to next question. An EMF represented by E is equal to 100 sine 100 pi t is applied to an RL circuit of R is equal to 40 ohms, L is equal to 0.1 Henry. Find the inductive reactance. Now here the equation what is given for the EMF is E is equal to 100 sine 100 pi t. Okay, and we have R is equal to 40 ohms and L is equal to 0.1 Henry. We should find out what is inductive reactance XL. XL is equal to 2 pi FL. Okay, now how much is F? So F we will get here. This value is 2 pi F. So 2 pi F is equal to 100 pi. So here F is equal to 100 upon 2, which is equal to 50 hertz. F is equal to 50 hertz. So here if you put that in this value, 2 into 3.14 into 50 into 0.1 Henry. 0.1 Henry. This is nothing but 100 into 3.14 into 0.1 Henry. So 100 into 3.14 is 314 into 0.1, which is equal to 31.4 ohms. So the reactance is given in ohms. So this reactance of the inductive or reactance of the inductance or inductive reactance XL is 31.4. So option C is the right answer here, 31.4 ohms. So here you can see option C, that is 31.4 ohms is the right answer. Then we'll go to next question. A machine which converts mechanical energy into electrical energy is called as. Obviously, it is called as generator. Generator is a machine which will generate electric energy from mechanical energy. And similarly, the opposite machine which will convert electrical energy into mechanical energy is motor. So here in this question, a machine which converts mechanical energy into electrical energy is asked, and that is generator. So here you can see option C, a generator, is the right answer. Then we'll go to next question. In simple form of transformer, the winding to which AC supply is connected is called. So if you see the simple form of a transformer, then a transformer will be having a primary winding like this and a secondary winding like this. So this is your transformer. Now AC supply is applied. Okay, so if AC supply is connected to the primary winding, this is the primary winding, then this will produce magnetic flux, and that flux will be cut by the second coil. Mutual induction takes place. EMF is developed in the second coil, which is secondary. So in this question, it is asked that in simple form of transformer, the winding to which AC supply is connected is called as, it is primary winding. So here you can take the option as primary winding. So option A, primary winding, is the right answer. Then we'll go to next question. A PN junction is reverse biased when dash voltage is applied to the P or to the N side and dash voltage is applied to the P side. So if you see a PN junction, say this is your PN junction, P-type semiconductor and N-type semiconductor, and if you want to connect it in a reverse bias, then P has to be connected to the negative of a battery and N has to be connected to the positive of a battery. Okay, so if you connect P to the negative of a battery and N to the positive of a battery, so here when a positive voltage is connected to N side and negative voltage is connected to P side. So here option A will be the right answer. Then the PN junction is in reverse biased. So here positive voltage is applied to the N side and negative voltage is applied to the P side. Then only the PN junction is reverse biased. Then we'll go to the next question. The reverse current in a junction diode approximately doubles with every dash rise in junction temperature. So how much is the rise in the temperature? So that for that rise, the reverse current doubles in a junction diode. So there it is 10 degrees Celsius. The reverse current in a junction diode approximately doubles with every 10 degrees Celsius rise in the junction temperature. So option A is the right answer here, 10 degrees Celsius. So the reverse current in a junction diode approximately doubles with every 10 degrees Celsius rise in junction temperature. Okay. Thank you, students.